Hello and welcome to my video about measurement corrections and Trimble 4D control. At first I want to give you some background information, then I want to show you how the temperature and pressure corrections are working, then I want to explain the measurement corrections and show you some examples. Let's start with some background information. In T4D server, we have a data receiver or data collector module which collects the rounds from the total station. In the properties of the data collector or data receiver module, the default values for temperature and the default refraction coefficient are defined. These values are used if no other value is provided. The terrestrial engine applies the measurement corrections. If you don't want to use the temperature information from the GKA file, you can select a temperature sensor here. Also, the measurement corrections are configured here. I will explain them later. The integrity monitor performs the adjustment and calculates the offsets to the reference points. If you are using the recommended workflow where the setup M1 controls the total station, you also have a temperature sensor connected via a serial cable to the setup M1. The setup M1 reads the current temperature and stores it in the measurement file, the GKA file. Here you can see the temperature value from the temperature sensor and also the pressure value which is coming from the total station. This file is downloaded by T4D and these values are automatically used to correct the distances. T4D uses the same formula like other Trimble products for the ppm correction. With the target raw sensor in T4D Web, the distance correction can be visualized by adding the temperature sensor here in blue, the raw distance and the corrected distance into one analysis chart. Here you can see that the temperature varies quite a lot, around up to nearly 30 degrees per day. The raw distance is also changing a lot over the time, around 2 centimeters. The green line, the corrected distance, is much smoother, and here you can see the good effects of the temperature corrections. The distance to this target is quite long. It was around 1 kilometer. So with shorter distances or less temperature variations, the correction would be smaller. Even so, T4D is correcting the distance based on temperature and pressure. Many customers still see daily variations in their charts, especially with longer distances. Here you can see an analysis from our Westminster demo system. We have variations up to 30 degrees. And you can see that the red, the height component, is varying around 2.5 centimeters per day. To improve the results, T4D offers the so-called measurement corrections. In the measurement corrections, T4D uses the variations in the control point, which must be accurate and stable, and apply them to the monitoring targets. The first chart shows the variations in a control point. The second chart shows similar variations in the monitoring points. In the last chart, you can see the chart of the monitoring point, which is corrected with the variations of the control point. This is, of course, a perfect environment. In our test system, we don't have a good example for measurement corrections, and so I asked one of our customers from Rio Tinto for some examples. Here you can see their setup. They have a stable total station in their own hut, the monitoring points with distances of around 450 meters, and the reference targets with distances of around 950 meters. And here another photo of the site. In their T4D server, they have a terrestrial engine with only temperature corrections. and another terrestrial engine with temperature and measurement corrections. In the measurement corrections, you can select the total station to calculate ppm correction and also vertical refraction corrections. In this case, both was used, but it's also possible to use one kind of corrections only. In the next step, you have to select the reference targets. And it's possible to define a maximum angle difference to a reference point. In this case, it was not used as 180 is entered, but you could define to only apply measurement corrections to the monitoring targets in the area of, for example, 10 degrees. So in this case, the white targets would be corrected as they are in the angle range and the yellow ones not. The last property here is to decrease vertical angle corrections. If you set this property to yes, you can enter a maximum coverage distance. If you enter 500 meter in this field and the target is 100 meter away from the reference target, 80% of the corrections would be applied. If the monitoring target is 500 meters away from the reference target, only the typed-in refraction coefficient would be used. Now it's time to finally look at some examples. In this chart you can see the height component of the target 37. The green line is the height component with only temperature corrections, and the purple one has the vertical refraction corrections enabled. The corrected line is smoother than the green uncorrected line. This chart shows the north component. Here the difference is not that obvious, but the purple line is still a bit smoother than the green line where only temperature corrections are applied. This chart shows the height component of the target 38. Also in this chart we can see that the corrected purple chart is smoother than the uncorrected green chart. So in summary, T4D offers two kinds of corrections: temperature corrections for distances and the measurement corrections. For measurement corrections, you need a stable total station, stable backside points with similar conditions as the monitoring targets. With measurement corrections, the observed variations of the control points are applied to the monitoring targets. Thank you for watching this video and check out the other videos in our channel.